just get started with this lesson, I do want to point something out to you. We're already on Module 5. At the end of Module 5, we will be having a test. So we've done Module 3, Module 4, and now we're on Module 5. At the end of each unit, our unit is polynomial operations. At the end of each unit, we have a test. So at the end of Module 5, we'll have a test. And so there are only 3 lessons in there, so that'll be next week, the test. You can count on, basically, this stuff is pretty simple at Module 4. Module 5 is also pretty simple. So the most challenging stuff on it will still be from that Module 3. From my perspective, at least, that will be still challenging because I gave you some pretty simple questions on that quiz, but you will have more challenging questions on the test. So remember the homework questions, right? The ones on the test will be more like the homework questions. Okay, so you guys have had plenty of practice. You've been quizzed on the basics of it. Most of you guys got pretty good scores on that quiz, so it's pretty fair to kind of go a little bit more challenging on that. But the point is, Module 3, Module 4, and Module 5 will be what your test is on. With that being said, we are going into Module 5.1 now, multiplying polynomial expressions by monomials. Okay, now, once again, your book kind of goes into this whole like algebra tiles thing. I'm not going to go into that. Instead of that, I'm just going to go right into the meat and potatoes of it. So if we take a look here, in order to start this, we have to learn how to multiply monomials by monomials. Okay, and remember, monomials are just single-term polynomials. So at the middle of page 170, example 1a is where we're starting. And it's already worked out in your book, so you can just follow along. But the point is, first I determine the sign. It's positive times a negative, so that's negative. 6 times 4 is 24. And then you multiply the 2 variables here, x cubed times x to the 4th. Now, when I'm multiplying 2 terms with the same base, what do I do with the exponents? Add them. So this becomes negative 24 x to the 3 plus 4 equals negative 24 x to the 7th. Simple as that. Okay? So this is something that you guys have been doing for a while. It's not really anything new to you. And it is drawing on what we learned in Module 3. So that's right there in your book. Next one is B. And this one you can kind of fill it in as you go. 5 times 7 is 35. Then it's x times x, so x to the 1st times x to the 1st times y squared times y to the 1st, right? And so again, I just add the exponents, x to the 1 plus 1 times y to the 2 plus 1 equals 35 x squared y cubed. You guys see this? Okay. All right. Any questions on this? Okay. All right, so go ahead and do number 4 now. It says your turn at the bottom of page 170. Do number 4. God bless you. Okay, let's go for it. 18 times 3. good. 54. Then I have to multiply the similar variables, so it's x to the third times x to the eighth, y squared times y to the sixth, z to the first times z to the fourth. 54. By the way, you don't have to actually write this step out. You can just go straight to this step right here, which is x to the 3 plus 8, y to the 2 plus 6, z to the 1 plus 4. I mean, in all honesty, I wouldn't be mad at you if you just wrote the final answer, but here is the risk with that, as always, is that if you write the final answer right like this, and then you get it wrong, then it's hard to get partial credit, right? Whereas if I see that you did, this step, right, and then I see maybe, oh, instead of x to the third, you put x to the 2 plus 8 there, and then this ended up as 10, well, now I know you knew what you were doing, kind of, but you just made a little mistake. Or if you put x to the 3 plus 8, and then here ends up as x to the 10, well, you just made a little mistake. You knew what you were doing, you see? So it's always good to show your work. All right, any questions about how I did that? Okay. So now we go on to multiplying a monomial by a polynomial. And once again, this is already in your book, so you can just follow along. It's pretty clear that because of those parentheses, I do what with that 3x? I distribute it in, right? That's the whole idea here. Okay. So so I multiply each term by 3x. So 3x times 3x squared plus 3x times 6x plus 3x times negative 5. Okay. 3 times 3 is 9. X to the first times x squared is x to the third. Plus 3 times 6 is 18. X to the first times x to the first is x squared. Plus negative, it's a negative, so negative 15x. Okay? And once again, I probably could have shown another step there. The x to the 1 plus 2 and x to the 1 plus 1. And that would have been a little bit of extra work, but it made it good. All right, and the next one is not fully filled in, so you guys can go ahead and fill it in if you'd like. Again, I distribute this in to every term. This becomes 2xy times 5x squared y plus 2xy times 3xy squared plus 2xy times 7xy. This becomes 2 times 5 is 10, x to the first plus 2 times y to the 1 plus 1, plus 2 times 3 is 6, x to the 1 plus 1, y to the 1 plus 2, plus 2 times 7 is 14, x to the 1 plus 1, y to the 1 plus 1. Okay? So I get 10 x to the third y squared plus 6x squared y to the third plus 14x squared y squared. That makes sense? Any questions on this? Okay. So go ahead now and do number 6. Do this one on your own. My helps class is today, after school. We do have a test coming up next week. Still feel rough on Module 3. Maybe you never sought that one-on-one attention for that. Simplifying rational expressions. Then you can come get some individualized help. I doubt that I'm going to have too many people here after school today, though I might have a few because there's no test tomorrow. So if you're just looking for a little bit of extra help, today might be a really good day to come. Now, with that being said, if everyone in the class comes, then it's less individualized, but some things you just gotta trust. All right, number 6. Bring it in. 2 times 5 is 10. A squared, b squared. 2 times 3 is 6. A squared times a to the first is a to the third, b. Plus 2 times 6 is 12. A squared times a is a to the third, plus 2a squared. Okay? I skipped all the steps because you guys should have done the work. But any questions on how I got any of that? Okay, if you didn't get that, you should be checking it and raising your hand if you need help. Okay. All right. So that's pretty much it. That's pretty much the whole lesson. Feel pretty good about this? Okay. Okay, nice. All right, good. So check it out. There is one extra bit, all right, and this is modeling. You'll find that very often in this class. Yep, of course. You'll find that very often in this class. We do like very kind of fundamental operations and processes, and then we'll take the next step and we'll say, okay, let's do a word problem with it. Let's see how we can apply this to real life. Let's see how we can model this, or we can use these skills to do something. Okay, thank you. So, so if you go to the next page, we see here that Harry's building a fish tank. So Harry is building a fish tank that is a rectangular prism. So I'm going to draw my rectangular prism here. To the best of my abilities. Okay, and let's call this the length, the width, and the height. So he's building a fish tank, and this fish tank is a rectangular prism. It says he wants the height of the tank to be 6 inches longer than the length and the width. Well, what does that imply about the length and the width? They're the same. So we know that the width equals the length, and it also gives us information about the height. The height is what? What does it say in that sentence that I just read? It's 6 inches longer, right? 6 inches longer than the width. So the height is equal to L plus 6. Simple as that. Now he needs the volume of the tank to be as close as possible to 3,500 cubic inches. What should be the length of the tank? Okay, so it gives you this piece of information about the volume, and it says find the length, and then it says round to the nearest inch. Okay, well, our volume equation, what's our volume for a rectangular prism? Anybody? Length times, very good, length times width times height. Okay, length times width times height. Now, we know our volume should be about 3,500, and we know our length, we'll just say is equal to L. Our width is also equal to L, so we're just plugging those in. You see that? So our width is equal to L, and our height is equal to L plus 6. So instead of W, we'll put our L there. And instead of our height, here we put L plus 6. Okay? Because remember, we're solving for the length of the tank, right? So then we just go ahead and multiply these in, or simplify. L times L is L squared times L plus 6. Okay? And then we go ahead and multiply that L squared in. L squared times L is L cubed plus 6L squared. Okay, and it says round to the nearest inch. Now, we can't really solve this equation for L unless we have a graphing calculator or some kind of computer or a method that we're not going to go over in this class. But we can do something else. What do you do if you're on the SAT and you have no idea how to do a question, but you have 4 multiple choice answers? Guess and check, right? Okay, so let's guess and check. What's a reasonable guess for L? It's a reasonable guess based on that equation. Shout it out. Go for it. Anybody? 50. All right. I'd say that's a pretty reasonable guess, right? It probably wouldn't be like 3, right? Because if it was 3, then I'd get nowhere near 3,500, right? So let's try 50. Okay, so I'll go into my calculator here. 50 cubed. Well, that's already 125,000, right? So it's a little bit high. Okay. But so let's try another one. Go ahead, shout it out, someone. 15? All right, so let's try that. 15 cubed plus 6 times 15 squared. Okay, a little high again. What's another guess? Somebody. 12? 12, 13. Okay, let's try 12. All right, 12, remember we're aiming for 3,500, so that's a little low. Let's try 13. 13 is 32, 11. Let's try 14. Okay, 14. So 3211 or 3920, which one's closer to 3,500? 13, 3211. So our length to the nearest inch is 13 inches. Make sense? And so what would we know about our width? Our width would also be equal to 13 inches, but what about our height? Our height would be what? 19 inches. Good. Okay, so that's how we model a problem like that. Okay, now look, as much as this was great, okay, and it's interesting to go through this problem solving procedure, really, what was the fundamental thing that we learned today that was different? Just bringing that, multiplying that in there through, right? Distributing that L squared to that. So we're multiplying the monomial with the polynomial. Okay. And then we'll do one more, and then you guys can start on your homework. Number 7, engineering. So this is at the top of page 173. So Diane needs a piece of paper whose length is 4 more inches than the width. Okay, so here's my piece of paper, here's my length, here's my width. Okay, and the area is as close as possible to 50 inches squared, 50 square inches. So the nearest whole inch, what should the dimensions of the paper be? So it's asking for the width and the length. Well, we know the length equals 4 more, so 4 plus the width, W. So length equals 4 plus W. We also know our area formula. What's the area of a rectangle in terms of length and width? Length times width, right? So we get area equals length times width, but then we replace that length with 4 plus W. Okay? You may be wondering, why don't I just keep it as A equals LW and then plug in 50 and then solve? Can someone tell me why that's not going to be good for me? Anybody? If I have one equation, how many variables can I solve for? 1. I can't solve for 2 different variables with only one equation. So I have these 2 equations, but I have to use them together. I have this equation, L equals 4 plus W, I have this equation, a equals LW. So I have two equations, but I have to use them both. So that's why I plug in. So area equals W squared, because it's W times W, plus 4 times W. All right? And it says the area should be about 50. So 50 equals W squared plus 4W. What's a reasonable guess for W? 5. Let's try it. 5 squared plus 4 times 5. I think that's 45. That's pretty close. Let's try 6 to see if that gets us closer. No. So width should be equal to 5 inches, which means the length should be what? 9 inches. Okay? All right. Any questions about that? Okay. All right, very good, class. All right, so the question now is, what is your homework? It is numbers 1 through 18. So page 173, numbers 1 through 18. Yes?
Could you go over number 9 on the homework?
Sure. Page 173, number 1 through 18. Sure. Number 9 is, I have to distribute this x cubed in here and here. So it becomes x squared times x cubed. You got it? X times x cubed. I'll just continue. X to the 2 plus 3 plus x to the 1 plus 3, or x to the 5th plus x to the 4th. Okay? Does that make sense?
Okay.
All right. Okay, so that's it. That's it. Any questions? You guys think you can get going?